Hello friends, welcome to the channel All Competitions. In today's lecture, we are going to discuss what is meant by proof, what are the different types of the proof. So let's see. So the proof is nothing but the statement which is try to say that particular statement is true, or you can say that the statement which is try to convincing that particular statement is true. So there are various types of proofs, and out of that we are going to discuss some of the proofs over here. So we are going to mention here one by one. The first one is direct proof. Second one is proof by construction. Then next one, proved by contradiction. Then proved by contrapositive. And the last one, proved by induction. Okay, so one by one we are going to take the examples with respect to construction, contradiction, contrapositive and induction. So let us see. In today's lecture we are going to see what is meant by proof by construction. So what actually we are going to do in this case? We are going to show the given statement by actual construction method. So let us take here one example. Multiplication of two odd numbers is odd. So what we have to do, we have to prove that multiplication of two odd numbers is 2. So let us see, is odd. So let us see, assume A, B, C are given numbers. Okay, so what I have mentioned here, A, B, C are given numbers. Here A and B are odd numbers, and we have to decide that, or we have to find out that C is an odd number. So as I mentioned here, A and B are odd numbers. I can write here A is equals to 2m plus 1. So what is the meaning of this? 2m. So 2m means what? M is any natural number. That number into 2 means it will be the even number. It will be even number. Am I right now? Even number plus 1. So whole will be the odd number. Okay. Then with respect to B, I can write here B as another odd number, which is nothing but twice of n plus 1. Clear? So that is the equation number 1, and this one is the equation number 2. So what is our problem statement? Multiplication of two odd number is an odd. So let us, what we have to do, multiplication of two odd numbers. So let us consider C is the resultant multiplication. We don't know right now what is the C. So C is the multiplication of A and B. Okay, so assume this equation number 3. So already we have A is equals to 2m plus 1, B is equals to 2n plus 1, means equation 1 and 2 with us. Then what we have to find here? C as an odd number, and C is nothing but A into B. So from equation 1, 2 and 3. From equation 1, 2 and 3, I'll be right here. C is equals to 2m plus 1 into 2n plus 1. Okay. So I will take the multiplication of this. So in this case, this 2m into 2n, okay, this one and this one, then plus 2m into this one, then next term 1 into this 2n, and finally this 1 into 1, 1 into 1. So if you go for the simplification, you will be got here 4mn plus 2m plus 2n plus 1. Fine. So if you see this term, every term or every parameter over here having either 4 or 2 or 2. So I can take here 2 as a common, and it will be gives here 2mn plus m plus n plus 1. So I am going to restructure this term, this whole term as this one as a first part and this one as a second part. So you can see in the first part 2 is the multiplier. So clearly you can say that this one, this number is even number. Clear? Because 2 is the multiplier and plus 1. So even number plus 1, it means what? Clearly odd number. So C is nothing but the odd number. So you can see here, if A and B are two odd numbers, then multiplication of these two numbers is an odd number. So hence that is the example of proof by construction. I hope that you got this. So let us see the next one. Proof by contradiction. Okay. So what is the concept over here? In the case of contradiction, let us consider one statement is given to you. Then what we have to do? We have to assume that that statement is false. Okay. And by assuming that statement as a false, finally, we are going for again another false statement, and finally the false will become a true. Means it will be whatever we are going to assumption over here. Means originally if statement is given to you, and with respect to that statement we are going to make that it as a false, and by considering that the given statement as a false, we are going to solve the examples, and finally we will be got the idea this one is a false. So false will become here true. Okay, fine. So let us see here one example, so you will be get the idea. So in the case of contradiction, you can see root 2 is an irrational number. Root 2 is an irrational number. So guys, what is meant by number and what is meant by irrational number, or what is meant by rational number? So let us see here what is meant by irrational number first of all. the number which does not having numerator and denominator, that is nothing but the irrational number. You can see irrational number which is not equals to p upon q, where p is the numerator and q is the denominator. So basically we know that root 2 is an irrational number, but by using the construction method we have to solve that. Okay, so let us see here how to solve this. So first of all you have to assume assume root 2 is an rational number. Okay, so as I am assuming here rational number, so what will be happen? Root 2 will be equals to p upon q. That is your equation number 1. Okay, are you understanding? Because as I am assuming, see, assume root 2 is an rational number, so root 2 will equals to p upon q, means root 2 having numerator as well as denominator. Fine. So as I am taking here this p and q as a numerator and denominator, there will be the possibility that this numerator and denominator having some common terms or factors will be there in between them. So by removing common term, or you can say factor, common factor from p and q, we will got root 2 will be equals to a upon b. So let us say this one as the equation number 2. Means what we have do, we have removed here common factor from p and q, and after that we got here root 2 is equals to a upon b. Means here with respect to a and b, they don't have any common factor. So that is the consideration. So now what to do? So let us simplify this. So what will be solution? A will be equals to root 2 into b. So say this one as an equation number 3. Squaring equation 3 on both sides. If I square this equation number 3 on both sides, the resultant will be a square equals to 2b square. A square is equals to 2b square. So what is the meaning of this? So you can say here, from equation number 4, a square is equals to twice of b square. So what is the meaning of this? So you can say here, square of a square is nothing but twice of square of b square. Square of a square which is equals to twice of square of b square. So you can say here, a square is an even number by using the property of square and even number. If a square is an even number, simply you can say that a is an even number. Fine. Yes. Now what we have to do? Let a is an even number, means it having multiplier as a 2. So I can write a is equals to twice of m. So let us say this one as a equation number 5. As a is a even number, so it should having multiplier as a 2. So a is equals to twice of m. Then from equation 4 and 5. So if I substitute this value of a in equation number 4, then what will be happen? This a square will become twice of m square, which is equal to twice of b square. Fine. So it will be 4m square, which is equal to twice of b square. These 2 will be got cancelled. Here will be 2. So you can write here b square is equal to twice of m square. So let us say this one as an equation number 6. So if you observe here in the equation number 6, b square, which is nothing but twice of m square, means you can say that the square of b is nothing but twice of m square. So b square will be even number. B square will be even number. Hence, you can write here, hence b is also even number. So if you observe here, a is got here as an even number, b is also got here as an even number, and what we have assumed here, with respect to this root 2, we having a upon b, and a upon b does not having the common factor, because you can see here, by removing the common term or factor from p and q, we will got, means already we have assumed that from this p and q we have removed some common factors and we got here a and b. But after solving the example, we got here a as an even number, b as an even number, means absolutely a and b should having common factor as a 2, means it become false. Means whatever the assumption, these assumptions whatever we made, it becomes false. Hence, whatever the things we have mentioned, root 2 as a rational number is also become a false, or it becomes a contradiction. This becomes as a contradiction. So finally you can say that root 2 is an irrational number. Okay, so that's all about today's lecture. I hope that you got what is meant by proof, what is meant by proof by construction, and proof by contradiction. Thank you so much for watching this video. In the next lecture, we'll be see what is meant by proof by induction, proof by contrapositive, and direct proof. Thank you so much.